Hey everyone, welcome. So, we all want our APIs to be snappy, right? Super fast and responsive. But what happens when you've got a back-end process that takes a long time to finish? I mean, a really long time. You can't just leave your users staring at a loading spinner, right? So, how do we fix that? Well, let's dive into a really powerful architectural pattern that's designed to solve this exact problem.
Oh man, you've totally been there. I know I have. You hit send on an API request, and that little spinner just keeps spinning. And you're just sitting there wondering, did it crash? Is my internet down? Should I just give up and go get a coffee? It's super frustrating, not just for the user, but for us developers too.
Okay, so let's make this super concrete with a real-world example. Imagine you're building the API for a massive e-commerce platform, and a user wants to upload their entire product catalog. We're talking like 10,000 products, all in a single API call. Now, is it reasonable for them to expect a response in just a few milliseconds? No way. Absolutely not. That, my friends, is a classic long-running process.
All right, so what happens if we try to tackle this the old-fashioned, synchronous way? Well, we end up playing the waiting game. And let me tell you, it's a game that nobody wins.
So, in a normal synchronous API call, the client sends a request, and then the connection just stays open. It's totally blocked, just sitting there, waiting for the server to do all its work and finally send back a response. For a huge job like creating thousands of products, that connection could be tied up for minutes, maybe even hours. Yikes!
And here's the kicker. Even a 10-second delay is often way too long. I mean, think about it. Anything over 10 seconds leads to frustrated users, annoying system timeouts, and honestly, a super fragile architecture that's just waiting to break. We have to find a better way to build this.
Okay, so before we jump into the solution, let's clear something up, because this is a super common point of confusion. When we say asynchronous in this context, what are we really talking about?
Right. This is so important to understand. On one hand, you've got async await in your code. And look, we all use it. It's fantastic for managing threads on the server, making your API more scalable, avoiding thread exhaustion. Great stuff. But, and this is the huge but, the client is still waiting. That connection is still open. What we're talking about today is something different. It's an architectural pattern, an approach to building the system that completely decouples the request from the response. The whole point is so the client doesn't have to wait at all. And that's the secret sauce right there. Decoupling the request from the response. Instead of making the user stand in line and wait forever, we're going to give them a ticket and tell them, hey, we'll let you know when it's ready.
Honestly, this is the best analogy for it. Think about ordering food at a busy restaurant or a food court. You place your order, and they hand you one of those little plastic buzzers, right? You don't just stand there at the counter staring at the cooks. No way. You go find a table, you check your phone, you chat with your friends. You're totally free. And then, buzz buzz, the pager goes off. That's the signal that your food, your result, is ready. We're going to do that, but for our API.
Okay, so this whole buzzer idea has a fancy name, the asynchronous request-reply pattern. Let's break down exactly how it works step by step.
All right, let's walk through this flow. Step 1. Your client sends that big post request with the heavy workload. Our 10,000 products. Pretty standard stuff. But step 2, this is where the magic happens. The server immediately responds. Not with the final data, but with an HTTP 202 accepted. It's basically saying, yep, got your request, I'm on it. And it gives back a special URL to check the status. Most importantly, the connection is now closed. The client is totally free to go do other things. So what's next? Step 3. The client just has to check in every once in a while. It pulls that status URL, kind of like asking, hey, you done yet? How about now? And finally, step 4. Once all that background work is complete, that status endpoint says it's ready and gives an HTTP 302 redirect, sending the client straight to the final resource. See? Simple, super elegant, and absolutely no waiting around. So, this polling pattern is awesome, right? It's especially great because it's pretty low effort for the client to implement. But it's not the only way to solve this problem. It's not the only game in town. Let's take a quick look at a couple of other popular architectural approaches. Okay, this table lays it out pretty nicely. First, you've got the request-reply pattern we've been talking about. The key idea? The client pulls a status endpoint, and the effort on the client side is pretty low. Then you have webhooks. This is where the server actually calls the client back when the job is ready. The client effort here is medium. It's a bit more work. And finally, WebSockets. This is where you keep a persistent two-way connection open the whole time. It's super powerful, for sure, but the client effort is definitely high. Let's dig into webhooks a little more. You can think of this as the don't call us, we'll call you pattern. When you make your request, you also give the server a callback URL, which is basically like giving them your phone number. The server says, got it, hangs up, goes off and does all the heavy lifting, and then, when it's all done, it makes a new callback to your URL. It's a really cool pattern, sometimes called reverse APIs, but it does mean the client has to have its own endpoint ready to receive that call.
And then you've got WebSockets. If webhooks are like the server calling you back, WebSockets are like opening up a dedicated private phone line between the client and the server. The connection just stays open, and they can both talk to each other freely whenever they need to. This is amazing for stuff like real-time chat apps or live stock tickers, but it's generally overkill and less common for most public APIs. You see it more in internal systems.
Okay, so let's wrap this all up. What are the key things to remember? First, long-running tasks will just wreck a standard synchronous API. They'll block it and cause timeouts. Second, the solution is the asynchronous request-reply pattern, which completely decouples the initial request from the final result, just like that restaurant buzzer. Third, the key ingredients are that immediate HTTP 202 accepted response and a polling URL. And finally, putting this all together creates a system that is way more robust and a much, much better experience for your users.
So that just leaves one final question for you. The next time you're building an API that has to do some serious heavy lifting, you got to ask yourself, is my synchronous architecture actually holding me back? Is it time to stop making my users wait and give them a buzzer instead?